Good evening. Good evening, everyone. So, Queen CC Thermodynamics ki third super class hoy gadani ka. The first two classes the Queen a number theories ke kama ma naina gray odagi kedo what first law of thermodynamics naina gray odagi part function odagi state function ka or state variables RCI adu naina gray, and then different types of thermodynamic processes naina gray aduga moigi work done ke kama ma naina gray ka. So, makatausi. Let's proceed. So, handaki upcoming kaidoba Sunday sida kuina togodiba test si kinuni ka kai chakre. Yeah, handaki upcoming Sunday togdisi thermodynamics kinetic theory gani ka. So, kinetic theory zu thermodynamics ani maxi nangno takaduni handaki week sida ka. Auna sir kitang yangkat ke nasidi ka. Kitang tuzan ge ta. Aduna where we have to yangsi kayogre. Noi doubt gumbalaiba anything any question from thermodynamics from anywhere you can ask. Okay, last class the kaya ura. Koi last class the sige si torom mane ka. Na koi ngarang sige state functions or state variables or the part functions or part variables. The thermodynamic functions or variables you can state and part and kai doi state sidam ko extensive intensive and kai doi ngarang to break ka. So noina ngarangi class yahoo do bakangbu recorded video yengo recorded video do yaw ni ka. The question hot the molar heat capacity at constant pressure, molar heat capacity at constant volume, and then some thermodynamic processes, the isothermal, isobaric, isochoric, adiabatic, CC, no have to do. But then the relationship between the state variables, the different laws are there. So Boyle's law, Boyle na kay harami, Charles na kay harami, Gay-Lussac na kay harami ka. Adain taw na matang na agree. So sige Charles spelling is land male. CHARLE ka S at magi masagi mamingda LES the observer CHARLES ka Charles law, and then Gay-Lussac's law, then Avogadro's law, then universal gas law, blah blah ka. So Citogre last pasta. And then work done in different processes. The work done in isothermal process itare, work done in isobaric process itare, work done in isochoric process zero ni, always zero ni. Work done in adiabatic process na sita gimne ka 1 minus gamma. Now gamma is kaina gamma is Cp by Cv ni ka. Gamma is Cp by Cv ni sila Cp by Cv si gamma ka ka. And then we have the relationship between pressure and volume in an adiabatic process si kuina I have the Cg P1 B1 to the power gamma equal to P2 B to the power gamma na da ulitin ka. So see the 2 ma hinjil malit to is okay, sige 2 is misplaced where I'm sige 2 is ka. See the leg sige 2 is ka. Anyway, so kung ngarang si puli to ka. Tuga question mo hot kibra. Yes. So for monoatomic gas, a Cp Cv gamma Cp gre. CC sir na proof to 3 ko noida. Proof to 3 kain the kinetic theory of gas the proof to gin tham mini ka. Sigu muka tak the kinetic theory of gas kem yaw dreta. Aduna matam chana talake. I question of the sin of is in a tato. Now, I see the tau the Saruk Machet day, Sigi pressure volume mark the labor relationship in an adiabatic process. CC, see you ka. Now, I see the topic Masam Hapsan Geka. Adiabatic process. Adiabatic process ina different types to have how to define which of the following is an adiabatic process ka Hamilton the adiabatic process the du dq is equal to 0 RCI. Adiabatic process the or dq to 0 or du do minus p dv RCI. So minus RCI. Aduga atopa atopa di I have the p v to the power gamma is equal to constant RCI, or hierga P ko P zena suppose in V zi manganing in color zebuko aduragadi P lani ko so B di kaino have the nRT by P nina 1 minus gamma T to the power kadoba nRT B is equal to nRT by gamma ko gamma is equal to constant RCI. Natragana number 4 the V ko to the power gamma minus 1 kaino di PZ nRT by V nebuko. Yes, nRT by V. Aduna B to the power gamma minus 1 T to the power gamma is equal to constant. So minus RCI buko. Now, no in the C is adiabatic process ni, C is adiabatic process ni, C is adiabatic process ni. Sir, CD command la in one hamatam na akoina kai khangi have the PV to the power gamma is equal to constant lere. Akoina kai khangi PV is equal to nRT neba. Adu ene P je manga ningagadi V is equal to nRT by P have ya. Auna aina kidoba V manga ningba adu P hani V to the power gamma gi mo to kidoba nRT by P whole to the power gamma is equal to some constant hydrogen some constant adu ivatargadi P harga 1 minus gamma T to the power gamma is equal to constant r yare ko gyan tabro ta dabro ma'am tabro kanam ko mukti ji kai gino hello Rosban Tabra, Rosibina, Sintoi, Lakshmi, Anjali, Chaita Boss, Tabro.
Sir, tay.
Tay ko. Atay si away. Kang kumagtrain to. Cheto ju kumawda na ba. Sintoi tay, Rosibina tay, Lakshmi tay, 827. Hajik lo kumayja. Okay. No lo na mag chat party lo na mag chat lo na shift over na. Okay, fine. All right, fine. Yeah, let's proceed. Dumain to na koy na kedo ba? Koy na na. 시를 타는 거 누가 이제 시를 떠볼까 aduga amana ka PV to the power gamma is equal to constant habiti this is an adiabatic process ni dun ka uda aina kedo ba P among mangal lagadi kena nRT by V and then B to the power gamma is equal to some constant aduragadi V to the power kailani gamma minus 1 T aina sida B to the power gamma minus 1 sida gamma so this is where ka T de gamma error ka okay the is it right? Yeah, ka PV. So had the P is equal to nRT by V name. So nRT by V name ka aduna T haraga B to the power gamma minus 1 ka. So T haraga B to the power gamma minus 1 or V to the power gamma minus 1 T ka is equal to constant. So CC khangjalu ka which one of the following is an adiabatic process haraga no power zida kaigumba CG form zida piramasu sisu dum chummi CG form zida piramasu sisu dum chumme ko si loina mak chumme ba gyan tai ta de yeah bro no response yeah bro ma'am
Yeah, sir.
okay fine yeah aduti makatos makazi kaino makasi question hot kadawara okay fine makazi question hot kadawara ma question hot chika 네, 강그다밤나 서너시대 얌나 오이네 디덕션 그라바 파잖아 디 디케니까 네 강그담 시가지 CV plus R is equal to CP 시주 강그담니까 네 have the we have the Sibudi adiabatic process ki lecharedana ko message lai. Kai nuin khangadaba amna Cp minus Cv is equal to R. Cp divided by Cv is equal to gamma. Sisu khangadabane ko. Adumaina asisim khangadaba. Aduga polytropic process ki taksira. Question dum taage ko. Kisu maybe am kan important di oje but polytropic process ke ma yaw to ka kind. Question number 7. If Cp and Cv denote the specific hits per unit mass of an ideal gas or molecular mass with M, then now, question number 7 see ID question number 7 ji tawzira tawrasira yagadra saja hainaro. So noi kumaktamina sarum tawrage ka. We have the have the normally Cp minus Cv is equal to R nebako. But moina haji Cp is per unit mass hariba. Honestly the unit mass by mm yauriba. See the by mm yauriba. Do the kedoba. M do asom pura di sida ama hadi mm na 2000 the yauriba. Yantai kaisa tade. Ngawra. Option number kaitani is D tani. Gyanta bro.
Sure.
Kaino this is the per unit mass na ma high moina Cp is real Cp do nateba Cp by m neba aduga Cv by m neba se adudi Cp by m ga Cv by m ga Cp the onthod ke mass am lo into to neba the mass na on to into to ga Cp by m the Cp ole Cv by m the Cv ole mass am into to som the mass am into to ne na mr haigera or rm haigera ko doesn't matter, it's the same thing. So sita ne ko Sinthoi Gyantabra, Rosibina, Rosban, Redmi, Hagatoy, Sahila, Lakshmi, Setobos, Anjali. Gyantai ko?
Sure, C type.
Option number kay tayo ba?
C.
Okay. Option number C tayo ko. Mas to som na into to dia som pura di makala ka daw. Mitay siya. Thank you. Thank you for pointing out. Option number C ta din chume. C R by M. Kay ginawa mo itong mass na into to ay haidina. Habidi M times of Cp is equal to Cp. Mo yung Cp ton by mo to kanam thola mo jupa dam ne buka. Cp dash ay age. Of the M times of Cv is equal to Cv dash ne ba. Auna Cp dash minus Cv dash is equal to R ne ba. Adu agadi Cp minus Cv hay agadi M do sompura agadi R by M tadu. Yay ko? Yarbo ma'am.
Yeah, sir.
Yare ko adugin sumaina. Mass to asom do pura agadi makada lakani ko adugin. So dumaile. Makada usi. Okay, fine. Ko. So this is the question number kya na? 7, question number 8. Ko. Chumika in ito So if the ratio of specific heat of a gas at constant pressure to that at constant volume is gamma, the change in internal energy of a mass of gas when the volume changes from V to 2V at constant pressure is because if the ratio of specific heat of a gas at constant pressure, sir, okay, yes, Anjali, no worries, it's okay, Anjali. If the ratio of specific heat of a gas at constant pressure to that at constant volume, Cp by, again, more P again, Cp by Cp gamma, the change in internal energy of a mass when the volume changes from, okay, fine, V1, do na V ni haro, ka. kaiba V1 is V and V2 zina 2 times of V and at constant pressure adudi delta P zina kaino 0 aita yare ka adudi kaidoba moina is the change in internal energy puthoiba delta U puthoiba. So delta U z akhina kai khangi matamda delta Q minus P delta V ne ba. Now the change in internal energy ka at constant hello kanano jikita yarba yare ka okay fine yeah. So the change in internal energy of a mass of gas when the volume changes from V2 to V have never ka aduna constant pressure danina CCina I can use this as but adu kanabra kanadabra have the one delta QZ ina N CP delta T and season of the but again delta T z kai the gi kai kino tawni kento kanade ka aduga atopa kai sinabi minus P delta V. So delta V would be P minus P harga delta V d 2V minus V never ka aduna silere now CP ga sigi delta T z ga never ka fractize aduna delta T z mu kaina kai khanbe ya matamda sidagi ka moina puthoji kaino change in internal energy ne delta T. Okay fine. So kaina kai khange the PV is equal to nRT lere adu orga delta P d 0 nina P delta V is equal to nR delta T lere aduga P delta V is kaina the P harga 2V minus V is equal to nR delta T lere 2V minus V di PV is equal to nR delta T lere adudi delta T di kai lere ne have the PV by nR lere ne ko seasoner ni sida ko seasoner answer dum tarani de ka aduna n lere CP lere delta T ki muta kai dowa PV by nR minus PR to V minus B to V lere ka. Now constant pressure change in gas se adune dane kem high de ko mo intuition. Okay, fine. So n ga so okay fine. So n ga ka kreba ka. Now CP by R na male howe ka. Okay yare moina pam se kaino khange. Moin pam si gamma gida in terms of gamma they expressed over pam mane ka aduna ko expressed over birani. Not a big deal. It's a very simple question ka. Now hazik sir torki ka munyo. Aduna kida we have the aina PV common lore adudi CP by harga R gi motaina CP minus CV minus 1 and sumai ireba ka aduga sisi ingatang matakta chingkhatki ka aduga kaidawni ha matamda makha tawsi so delta U is equal to harga PV harga CP zina makhadi keno tawtharakpa matamda ko yendarakpa matamda kaitani have the 1 lere so adagidi CP by CP d 1 minus harga 1 by gamma lere ni ko and then minus 1 lere ni so which is equal to PV harga CCD kai lere ni matamda gamma by gamma minus 1 ang lere ni adudi CD kai lere ni have the gamma minus gamma plus 1 d 1 by gamma minus 1 PV gamma minus yes 1 by gamma minus 1 PV 1 by gamma minus 1 PV option number kay tani A tani ko so yung A tabra ma'am no response respond to Rosban tabra option number A tabra sayla Rosban je khumdi khumi do tadre Rosban khumi je kemta
Tại sir.
Taika okay fine Taika all right fine ka so makatausi ꯍꯥꯏꯗꯤ ꯅꯣꯏ ꯍꯧꯖꯤꯛꯀꯤꯗꯣ ꯑꯗꯨꯝ ꯁꯔ ꯒ꯭ꯌꯥꯟ ꯇꯥꯗꯦꯅ ꯍꯥꯏ ꯒ꯭ꯌꯥꯟ ꯇꯥꯗꯦ ꯍꯥꯏꯔꯣꯕꯀꯣ ꯁꯔ ꯑꯗꯨꯝ ꯇꯧꯒꯦ ꯌꯥꯔꯤꯒꯩ ꯀꯣꯏꯁꯟ ꯈꯔ ꯌꯥꯝ ꯍꯣꯠꯁꯤꯀꯣ ꯑꯩ ꯊर्मोडाꯏꯅꯥमिक्ꯁꯇꯤ ꯌꯥꯔꯤꯒꯩ ꯀꯣꯏꯁꯟ ꯌꯥꯝ ꯍꯣꯠꯅꯤꯡꯉꯤ ꯀꯩꯒꯤꯅꯣꯗꯤ ꯗꯤꯐ꯭ꯔꯦꯟ ꯑꯦꯁꯄꯦꯛꯇꯣ ꯅꯣꯏꯗ ꯀꯣꯚꯔ ꯇꯧꯅꯤꯡꯉꯦ ꯍꯥꯏꯇꯥꯔꯦ ꯀꯣꯏꯁꯟ ꯃꯌꯥꯝꯁꯤꯒꯤꯀꯣ ꯑꯗꯨꯒꯤꯅꯤ ꯑꯗꯨꯅ ꯁꯤꯗꯅ ꯀꯩ ꯌꯦꯡꯉꯨ ꯍꯥꯏꯔꯤꯕ ꯁꯤ ꯀꯣꯏꯁꯟꯁꯤꯗꯅ 1 mole of an ideal gas requires 207 joules of heat to rise the temperature by 10 Kelvin when heated at constant pressure. If the same gas is heated at constant volume to raise the temperature by the same 10 Kelvin, the heat required is so simple. Now, sida yung common has kidoba delta Q at constant kidoba pressure. Delta Q at constant pressure is kaino have the NCP delta T neva ko adu kaiga maneva 207 joules neva. Or the delta Q at constant volume do put one neva is equal to what have neva. Again, they got C is delta T at constant pressure again. And I think we see how to share the German opponent. Adudi si puto hamne so delta Q at constant volume di CD mukaino amatam da NCV delta T ne NCV delta T is equal to what hangmane so simple na adu regadi akoina kidawi amatam da atai di atopa kai information pirami yes atopa information amna delta T is equal to 10 Kelvin and piram yare ka again same adum asigi hadi delta T1 delta T2 is loin 10 Kelvin ngatane buka aduga r gi value su pirami moin to is r is equal to 8.314 ni so 8.3 joule per mole and Kelvin na ka gaina pirami so adu oiba taragadi akoina zik kamaina tawjige habduni ka makada tawjika du de audi akoina kai khangi habda sigi delta kari Q at constant volume puthoiba ko so delta Q at constant volume is equal to n can I write like this Cp minus R and delta T yareka now the kedu we have matamdane moina keno torom deba ko kai moina sigi CPC habdi moina monoatomic ni diatomic ni adu ada kan piram deba ko ana koi sumai hot tamne kaigino since CV is equal to Cp minus R ne ba ko Cv um pa here n Cp delta T minus nr delta T lere ko so do the hochalo dum answer tarani na sidi khangani na ko ncp delta T di moi pyramid to 207 na minus n di kena 1 mole 1 r di kena 8.3 delta T di kena 10 audi kai tara audi 207 minus kai lerani 83 adu di kai tarani 7 minus 3 di 4 2 aduga 124 joules 124 joules tabriyo ma'am no response tayo ko Lakshmi tayo in hereka okay fine so now let's proceed keno to noise respond amda to nurtragadi factorani to is Anjali budi chakcha basang weekend haijarame ko ma chakcha loiragi observe jani atai Sahila Rosban Rosibina Sinthoi ko Lakshmi Chetakume so gyanta hubro
sure.
tayo ko okay fine all right so let's proceed question number question number 9 la yes question number 10 thermodynamic state variables and equation of state ka let's see question adum mathang solve sum tawtharage ko id yam laimal lagadi tawroi ko id noi dum take sumai tawde a cylinder contains hydrogen gas at pressure this and temperature this its density is sidiam like ꯉꯝꯒꯗ꯭ꯔꯣ? (27°C ꯅꯣꯏꯅ ꯀꯦꯜꯚꯤꯟꯗ ꯑꯣꯟꯊꯣꯛꯀꯦ ꯍꯥꯏꯗꯤ 273 + ꯇꯧꯔꯒꯗꯤ 300 ꯀꯦꯜꯚꯤꯟ ꯇꯥꯔꯦꯀꯣ. ꯏꯠꯁ ꯗꯦꯟꯁꯤꯇꯤ ꯑꯗꯩ ꯃꯣꯏꯅ ꯀꯩꯗꯧꯕ R ꯁꯦ ꯄꯤꯔꯝꯃꯦ, ꯀ꯭ꯂꯨꯅꯤꯀꯣ, ꯄꯤꯔꯝꯃꯤꯁꯦ 8.3 ꯖꯨꯜ ꯄꯔ ꯃꯣꯜ ꯀꯦꯜꯚꯤꯟ. ꯌꯥꯔꯦꯀꯣ. ꯑꯗꯨ ꯑꯣꯏꯕ ꯇꯥꯔꯒꯗꯤ ꯃꯣꯏꯅ ꯄꯨꯊꯣꯛ ꯍꯥꯏꯁꯤ ꯀꯩꯅꯣ? ꯗꯦꯟꯁꯤꯇꯤ ꯄꯨꯊꯣꯛꯑꯦꯕ. ꯗꯦꯟꯁꯤꯇꯤ ꯔꯣꯗꯤ ꯀꯩꯅꯣ? ꯗꯦꯟꯁꯤꯇꯤꯗꯤ mass by volume never. Yareko. So mass by volume, okay, fine. It contains hydrogen gas. So other molecular mass pressure ga temperature ga dang piramba ko aduga kaino putho'u haiba ko adu ergadi na magi volume volume jidi kaino v there ko, and then pressure dagi kamai to on toxige have the one ko T, so T adagi kay on the PV is equal to nRT. Okay, fine. N is the number of moles ni sida ina kino tawbo ko kay gamba ina N sida M ma hapsalagadi ka this is just number of moles ne ko the magi molecular mass to hapsalaga sigi volumes na yelagadi cc rho idene RT. But again sida the PM la ne ko NM mass, total mass haitare, number of moles, and magi kedobag sisina gram molecular mass ni ka adu di total mass by volume di kaino have that rho RT la ni. So rho putwa nina PM by harga RT. So rho is equal to PM by RT tare ko. But again gram molecular mass of hydrogen di kaino 1 ko. Aduna 1 gram ne tare. So which is equal to pressure di kya no? Pressure di 249 into 10 to the power 3, and M di kaino M di 1 into 10 to the power minus 3. Hydrogen 1 and option di ka R di kaino 8.3 and temperature T di kaino 300. This is the kanuwaitaba number ni ne ko. Siga kakre aduga 249 lehore mathakta, and C point siga kakre kalol di 83 into 30 di 0 am lerni aduga 339 am lerni 8324 249. Oh, CD 1 by 10 butaine 1 by 10, which is equal to 0.1 kilogram per meter cube tabreng ma'am. Option number C je tabreng. Rosbanji kumaira kumaktirangde. Lakshmi, Anjali, Saila, Rosibina, Sintoy, Rosban. B taeba ko. B have the 0.2 gram per meter cube taera. Rosibina B taen haine. Adu ergade gizi swerba. Te yengizi ko kaide suena. Kaide suy gizi bo. 339, 8324, 249 and tab. M. Oh, I'm sorry. Molecular mass of hydrogen is 2 ni ko 1 nate. Atomic mass of hydrogen is 1 ne ko 1 gram ne gram atomic mass. But molecular mass is 2 ne ko auna si 2 oigadaba. Havadi sida yaw is kaina this is hydrogen gas C molecular mass oigadam ne ko. I'm really sorry. So this is 249 into 2, so 2 by 10. 2 by 10 ni kaino 0.2 tagadaba. So option number B is the right answer. Gyan taubra taudabra. Habidi hydrogen se H ki habidi kayani kaya dino mu haizira mu hargadi kano dala ni ko atomic mass unit la ni natragana unified mass la ni ko. So kaya we have the gram molecular mass ko of hydrogen m haidare ko of hydrogen sa kaya we have the 1 gram neba ko aduga m of hydrogen molecule na kayno 2 gram neba. Now we should use this, not this. Asi is sinaroi because you in sinaneba. Adugi wanida. Gyan butao bro ma'am. Ram kumak trito is. Noi lo em chet oina kum mazena noi ma'am yana gat tawira ba. Sela tabra. Gyan tao bra.
hydrogen ji molecule 2 gram oidoi ya kamain khangdoi.
Kamay khang duino ba. Hydrogen atom amagi masi 1 union has you the 1 point something. It's just like 1 unit. One you have the 1 atomic mass unit has you but nana we have the hydrogen gram or c the mole concept and label Avogadro's number natragana 1 mole of hydrogen atom low the 1 gram but hydrogen atom ni ko reality the atom z independently exist ngamdamnina hydrogen ji molecular form the layeba auna nangna kaidongni ha matamda hydrogen molecule si nangna 1 mole lobo matamda magi mass 2 gram oiganiba 1 gram oiragadi kahani kano mole ama pharoi mole tangkhai but mole tangkhai di longna deba ko mole ama loguduneba ana hydrogen mole ama lorgadi 2 gram kaino di hydrogen molecule si H2 oeba avna H amagi 1 ina H ani gi di 2 ni dana avna 2 gram oineba noi kano khangma natro mole concept khangma natro mole concept hai kenate atom natraga molecule ama ji 1 mole lorpa matamda magi mass to amu or u the irambadu z the olakadoneba have the for example let's say anything have the hydrogen let's say kai has the genoina atopa nitrogen hayone ko nitrogen gi si nitrogen atom amagi mass kya no khangbra 14 ni dana ko nitrogen atom amagi mass 14 u neba adu nang nitrogen mole ama nitrogen atom do mole ama lor gadi kai oine 14 gram oineba aduga nitrogen molecule amagi mass 28 u neba so 28 u si nang nitrogen molecule do mole ama lor gadi kedo 28 gram or kadeneba nitrogen molecule n2 you are in question hai cha gyan tau bro
Tarsa.
ka okay so noi mer ta tai di loi na mak chet kangbu ata on grade to is anyway fine question number C which of the following is not thermodynamical function in haika enthalpy Gibbs energy internal energy work done now si loinamak si thermodynamical function nga tani si question ji mo aje question ji lale which of the following is not a thermodynamical state function state function kai no di moi loinamak thermodynamical function nga tani ko awda ahum amadi state function oeba amadi state function oidi sina part function ne ko work done je aduna option number B je taramani ko option number B tabriang kai no B je khatang tongan taiba enthalpy है state function ni Gibbs energy है state function ni internal energy है state function ni loinamak state function ni only work done je tongan tai so work done je part function ni ana mazi moina si the thermodynamical function है state function do idune ko so question number 11 ki option number kai taba work done je tabriang option number B je tabriang kananum di kumauda tai ko okay fine jet to kumak le is anyway fine no praktar gari kai pale 2 cylinders blah 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 in which of the following adjacent and those dum question gi matungin am those Okay, two cylinders A and B of equal capacity are connected to each other via a stopcock via RCI. A contains an ideal gas at standard temperature and pressure. B is completely evacuated. The entire system is thermally insulated. The stopcock is suddenly opened. The process is so simple. Kayo ni haro? Kayo ni adiabatic oigadeba. Kaigino hay matamda noi asigi question di gyan tabro tadabro. Noi kanam kumak train tawis. Suana hanjan.
सर टेम्परेचर का प्रेशर का सी कांस्टेंट हो जाएगा
temperature, pressure, the constant right? No change tawdani. Sa harke taw ka. Noi ji kumdaba mina masing yam kale tawis. Comes to ID something like a stop cock layer get over balloon I get let's say the chamber at top layer. So let's say this is A and let's say this is B. Now A contains an ideal gas at standard temperature and pressure. Magi kidoba maiji PA and VA and TA linear temperature. Yareka. And mangundu di kemte yom deva. Mangundu di kemte yom deva. Now next is ngatang layagadi kidora kani. Ngatang layagadi sigi stop coke se logthokraneva. Yareka. Auna aina sigi stop coke na thingambase isi logthokraeba. Yandabra. So logthokibdaidi kaidora kani ya matamda si gas loin changaga som side to loin laane. Yareka. Aduna di kaidora kani have the CPA je PA oigidra oeroi. PA dash oirani, PV dash oirani, TA dash lani, and magisu pressure amlani, and magisu kaidova volume amlani. Yandaiga, sigi chamber sigizu again and my temperature amlani. Loina di kaidoni amatamda aduga kari the change lakani duzu high zebako. Pressure z obviously handarakani. Temperature expansion to wena handarakani. Volume di hengalai. But heat T, delta Q di kaino, zero never. There is no heat exchange in this process. Just gas to som nakanda katang layam do si hangdok pade asom da chalak pade di gas se expand to rehab di my volume do hiya na phange. Expansion causes cooling. Expansion tauram ni na magi pressure ju obviously handarakani, temperature ju handarakani, volume na hengalakani. But heat exchange it has to be an adiabatic process. Gyan tay tade. Taika. Okay, fine. Lakshmi Tare. Yareka. Now let's proceed. In which of the following process heat is neither absorbed nor released by a system? Kayo idino? Question number 13. Kayo di ba? Kanang ko mag-train to. Yeah. Yes. Adiabatic Vajinika. Very good. It's a very simple question. No? So CC 2018 gizino shoftong mudra the volume of a monoatomic gas varies with its temperature shown in the figure. The ratio of the work done by the gas to heat. Blah, blah. Okay, so it's a very simple question. Dahil kayo na P kayo na V ni ka. CC haro kayo din haro. V by T is equal to constant na. V by T equal to constant na di kayo na. V is directly proportional to temperature. The pressure is constant. It implies pressure is constant. Constant pressure di kayo na. constant pressure the Charles law the the volume of a monoatomic gas varies with its temperature shown in the figure. The ratio of the work done by the gas to the heat absorbed. So work done delta W by delta Q is equal to have a constant pressure. The work done. So isobaric process ki work done ki formula do noi khangbra khangi ka isobaric pressure constant. So PV dum tarni ka P har the delta V dum tarni upai lete to the heat absorbed when it undergoes a change from state A to state B ka heat absorbed haiba ka heat absorbed ti nina constant pressure da nina NCP delta T budi haiba yai ka NCP delta T budi haiba yai aduga masida noina kaidoba yai hai matamda aikoina kai khangi PV equal to nRT ni constant pressure ni na P delta V is equal to nR delta T ni aduna delta V by delta T z noina kaino toba yai ka or whatever P delta V z kai ibe na sida nR delta T ibe yai aduga NCP delta T ibe delta T NN ka khre aduna R CP di kaino monoatomic ni na CP 5 by 2 ni ko CV na. So 5 by 2 R ni which is equal to 2 by 5. So answer si 2 by 5 tabre yung option number A tabre yung na. Check it. Kanam ko magtre. Wait, taribo.
Hi, sir.
Taribo ko. Okay, fine. Alright, yeah. Let's proceed. CE among there ba. Question number 15 zero. CZ itake ka. Sito din theory ma take ka. Kaido ba? PV diagram ka. Expand PV diagram. Kaido ba? Expansion. Compare to usi ka. Sila ni paibra. Sino chuma like ka. Aina usi to izi no ido kanjan gadra sino inkaliji ka. Okay, you know what happened? What happened? PV diagram. Wherever I click. This is for compression. So yang asi kamain tauge na ka. Ay nga tang si sino the kanjan bra so ay kanjan. Noida sir na so ay the cursor move to si kanjan bra noida.
Ande, sir.
Kanjan dev ka.
아이디 간절.
Kaya ba? Kanjan le. Okay, kanjalati. Adina aina kanjalam do man mai ta adugini ka. Kanjalagadi aina zik kanjalana ba tawrage. Yarba zikti.
없어요.
Okay, fine. Now, expansion. So here we have pressure and here we have volume. Now, kaya we have matam do ka. Volume hengat pa yung matung ina pressure si handara kadaw nebo ka. Aduna you have different types of graphs. So straight line yan ye kisi ka. Sumaina ma ye o. Sumaina ma ye o. Sumaina ma ye o. And sumaina ma ye o. Aduga compression ka volume handara pa yung matung ina pressure handala kadaw nebo ka. Aduna sumaina ma ye o. ꯑꯗꯨꯒ ꯈꯤꯇꯪ ꯁꯥꯔꯞ ꯑꯣꯏꯕꯀꯣ ꯃꯊꯛꯀꯤꯁꯦ ꯑꯗꯨ ꯑꯃꯅ ꯁꯨꯃꯥꯏꯅ ꯌꯦꯛꯀꯗꯕꯀꯣ ꯑꯣꯀꯦ ꯑꯗꯨꯒ ꯃꯁꯤ ꯈꯤꯇꯪ ꯐꯖꯕꯗꯤ ꯋꯥꯠꯂꯅꯤ ꯀꯩꯅꯣ ꯑꯩꯅ ꯇꯧꯔꯤꯁꯦ ꯕꯦꯛ ꯍꯟꯒꯦ ꯇꯧꯔꯒ ꯁꯤ ꯁ꯭ꯇ꯭ꯔꯦꯠ ꯑꯣꯏꯕ ꯑꯣꯏ ꯍꯦꯛꯇ ꯐꯩꯈ꯭ꯔꯤꯁꯦ Alright. So this graph is a little she's in a tongue that key. This is better. Yeah. So let me explain. Now, we have Sigi different processes like Sigi sina at constant pressure nina sisina isobaric or ni pressure hongde Sisizuka isobaric and sina constant volume nina sina isochoric.
Sir, so isobaric che mat chingdarappa jo do natro. Oh, natte. Yare sir sum.
This is isochoric. Yare ka constant volume. Mathangda sigisina khara thekatpasina adiabatic khara less thekatpasina isothermal. Aduga sisisu mathakise kaino khara less slope nembasina isothermal and slope yam yungbasina kaino this is adiabatic. Aduna noina kai aduga let's say kai haisige habda sisina process ke haisige karmada chachiga 1 2 3 4 ka sisina 1 haisira sisina 2 sisina 3 sisina 4 the work done in 1 is greater than work done in 2 is greater than work done in 3 is greater than work done in 4 in the case of expansion in the case of compression isochoric 1 2 3 and 4 so isochoric always kano tawzi aina 1 2 3 4 this is sanadre aina ngasai gidu kaidoba isobaric ta 1 thon gimni sida 1 tholage mathangda isothermal da 2 thon banina sida dum 2 tholage sidana 3 tholage and sidana 4 tholage compression dana work done in kaidoba work done 3 jina koi sarne diabetic mathang work done 2 mathang work done 1 mathang work done 4 and work done 4 di always 0 ne so sigi graph si gyan tabra si graph si always khangu habidi kaino habida processing se pressure ga volume is combined related oi habisi kayumba isochoric oiraga di pressure nang hongning hongjo volume di sung hongoiba aduna ba isochoric te constant volume neba and achamane mai the straight line sum aidam oini sida ju dum swain oini isochoric se and isobaric ta di kedoni ma volume hongira hongogira khangde pressure di hongba deba constant pressure neba swain ta on sida constant pressure line neba now kedo we have the my volumes increased or caragati it could be isobaric isothermal adiabatic isobaric the constant pressure de hangat kre but isothermal ga adiabatic ka je kedoni ya matamda ani ji kanane na slope si handarakani head pressure ji kanane na handarakani haiba matamda adiabatic tan hena handarakani bu ko adu kai yino na haiba matamda ko muneyong sida isothermal haragadi kaino habda constant temperature habdi mana kaigumba maji expand tawurakpa matamda magi kaidoni have the mong the expand the wise kind of work done never. Now work done ji we have the energy chung never. Aduma constant temperature to maintain to we have the demand so the key expansion the heat absorb to ni buka. Aduna maji kido can expand to ni but heat absorb labor gi pressure do heat absorb to wise temperature increase to temperature would increase would late but decrease to to dreva kay you know the isothermal o henna hit to amuk compensate to na hit to local level mana ko aduna di kay my pressure do aduki matik handaro just expand to thoki ba saruk tu gi oina just handara kaniba but adiabatic to di kay we have my heat absorb to ya de heat absorb to ya de release to ya de ba adu nang adiabatic ko hala nang expand to di kay magi temperature aduki matik drop to gra neba adu adagi amka temperature drop to re sir aduga ado kaidoni ha matam da temperature drop to re the external heat to changak tram nina my pressure do have the heat changak pai ji temperature hengal kaduni and pressure su hengat kaduni ba with kedawa temp heat pu changa di pochi temperature hengale and pressure hengale ba awna sida di sir isothermal kamai hengalina my handabam thokudo handa davida lehali ji kai heat changa ga temperature do khara hengal an maduna my handabam thokudo handa davida lei ne expand to orga su sida di expand to budo heat to chang pa yadam nina kai do kani pressure do duki mati handa gra ni ba ko gyan ta sir naning is isothermal da aduki mati handa ya ro pressure ji kai heat change ba kai no di isothermal da di ko temperature maintain to no heat chang ba ya now sumai to no compression da nang compressed option bada isothermal da di kadoni heat chang e aduna kadoni amatam da magi pressure do aduki matik kadoba sorry compression the heat se thoki doine heat thoki menina aduki matik hengaloi pressure se ko but adiabatic the heat to thok pa ya de nang compressed orgadi kador kane poche temperature hengale ba du temperature do na my pressure do jar la hengal halakani ko heat to escape to ya de adiabatic to so sigi graph ani ji kaidi sir na ji tai ji kaido boino adiabatic ne na slope se always heli je na auna thumb rule oina no khang du ji kai na da isothermal ga adiabatic ka se adiabatic na dum slope se hen ne ba slope hen bai di kai no yum tha ba hen ba thek ta ba hen isothermal na pa ai di kai ni kitang slope to kitang blunt hoi ba yam sharp oi roi ba my turn je ko aduga ai adiabatic ti yam sharp oi ni yung ba hen ne ba adiabatic na isothermal dagi yung ba hen ne ba yung ba hai di कहने हाइदर बाइगेरा हाइगत बाइगेरा whatever adu hi ne gyan butao bro ma'am no response taika so this is very important ka na isi yamna important oi sigi graph sing si diagram se phasana khanggadabani ka si khangradi ade so lakshmi tai hai ka atai di kanam ko makidre lakshmi ka kenoga anjali ga dang kume mayam keno to ribo class ti lon yaw ri to tabro rosibina tabro sinthoi rosban sahila tai ko so tai hai gyan su tabro tai hai gyan ta hai sir gyan ta dre ka okay gyan ta hai ko rosibina okay fine great now let us proceed question number kan to de si question number 15 je ka pung je ta hogi lem thermodynamic processes are indicated in the following diagram so noi hairo si ki sida karam boy dino si straight ta chat pajina kaino part 4 jina kaino isobaric part 1 jina kaino isochoric part 2 jina kaino adiabatic part 3 jina kaino isothermal part 3 jina isothermal 3 ga d ga ado moine sida kai p2 kaino moin to jugina o p deina c je p ga c ga je chumbre part 1 je isochoric oibra yes part 1 je isochoric oi chumi p ga c ga je chumi ka adu mathang dong ya si ni jim la lai q ji kai oi q ji kai no q ji part 2 ji kai no part 2 ji adiabatic oi ga da ba adiabatic ti kai a so the q ga a ga okay so option number a is the right answer option number b is q is d highlight si la le ka option number a is the right answer so no isi gyan ta bro
Tahu sir.
Tahu got that okay great now question number 16 to c 16 jo in kan to ke to ga kan be ado question oi le to is question number 16 ji hai bami yaw bra Sajakumnaro. 16G Kangmami Aubra. Sajakumo, Sajakumo. Yes, no. Anjali Kangbra. Saila. Rosban. Rosibina. Sintoi. Lakshmi. Kangbra Kangda Versa Dinero.
Khangde sir.
Atay di kanam kumuktiyan ito. Kangi Kangdi.
Khangde.
Kangde. Okay. Atay Chetor Kumuko. Rosibina Kumo. Sintoi. Whatever. So anyway. Okay, we have the 1 mole of an ideal gas, and there goes the process described by the equation. This is the heat capacity of the gas during this process. Okay, fine. Anyway, so PV to the power 3 is equal to constant now, the I derived the heat capacity of a polytropic process in a car. Masi sumain theorem derived to kaya okay, sidaisi tawag ko. Thermodynamic processes akoina hajiko tammi me anje loina polytropic ni ko. Polytropic haragadi we have the pressure ga volume ga gi marked relationship to constant hoiba haitare ka. ID whatever p to the power x v to the power y is equal to constant. CC polytropic process ni ka. Polytropic process. Aduna we have the all processes are polytropic. Adiabatic is polytropic ni, Isochoric is polytropic ni, Isothermal is polytropic ni, Isobaric is polytropic ni. Low in polytropic ngata ni. Yare ka? Now, kaidawi makatos. Kaya kay kangi. The kay delta U is equal to delta Q minus P delta B. Sisi first law ni ko kangi ko. Delta Q di kay no NCB delta T. Delta Q di kay no NC delta T. Sisi specific heat ni at constant pressure sunati at constant volume sunati kaim na te ka just NC dang hai. CN ka jan n kay no different to the power n lakh NCN ka jan lage ka for a polytropic process hai tare. No isi ang buti na ramgiro di na insan to is now minus P delta V na CC to ziko. Now okay. In general, the polytropic of PV to the power n is equal to constant ka. Adu no ida yang complex oi thoroge sumain torge. PV to the power n is equal to constant kan. Si dan torge. Adu oi bitaragadi ka. Now polytropic process ID sigi general pattern jidom advanchum laigadani ka. Aduna can I write like this? PV to the power n is equal to K. Aduga K together. We know PV is equal to nRT ni dalaga. Adi regadi P delta V. Okay, fine. Oh no, P delta V nati. Aina pa mi kay na. Aina pa mi si P motor ina sumain to yan bro. K by V to the power n ko. Yes, yeah. So K by V to the power n se no ina ngau gadra I dum step samjharoge ka into V is equal to nRT since PV to the power n is equal to K for a polytropic process. Asisi ni ko. Aduga di kayda we have matamda K haraga 1 minus n v to the power 1 minus n minus 1 or minus n learning dv learning is equal to nr dt learning. Adudi CCD amka kaidawi matamda k by v to the power n di kaino the p ne ba ko auna k 1 minus n p dv is equal to nr dt tare ba ko auna p dv is equal to kai haine matamda nr dt by k 1 minus n tabra not k is error. I'm sorry. See k is sizinagre ba k is error. Adu ergadi aina kai tare have the n loin ka kre n ka kre n ka kre n ka kre dt ka kre dt delta t has dt ka dt has delta someone d ka delta ka aina d yoin sinora ba d yoin sinora min ai si d yoin thori ba yare ka Aditi Kaitani have the CV is equal to Cn minus R by 1 minus N or to. Kaidaba Cn is equal to Cb plus R by 1 minus N. So this is the general formula for specific heat of a polytropic process. Yareka. So C is in a gyanta hubra. Kaidi gyanta de. Sazainero gyanta ita de. Kanam kumaro ito is. Gyanta hubra. Okay. Sing ko tai ko sing ke. Okay, fine. So kita okay. Si senoi de keshu hangoi ko. Kay di tiny yam tiny question di polytropic process no di yaw drum ay sum question yam takpan. No ni si the ngawram ba may yay du gine na pakali ko. Kay na have the key hana by b to the power n is equal to p ne ba si senoi. Yare ko. Since si ज्ञान उतारम दे तावदी तारम ने स्वयं लोग न दे का why do I do this Erika so smile okay fine do na silere do batare ka yare great karadi shift ho gaya na samjhe Erika okay fine adu di sigi question di solve torzi kay no si pb to the power n how di my cn do kay lani cb plus r by 1 minus n Now the CBD kano monoatomic di 3 by 2 plus CBD 3 by 2R plus haraga 1 by 1 minus 3R. Adu haraga kay tare 3 by 2 minus 1 by 2 3 minus 2 di 2 ni na ka. Sorry 1 minus 3 di minus 2 ni na times R which is equal to R tabre yung R tabro kanam ko magtrito is option number D tabro ma'am
Yes, sir.
Okay, fine, great. Now let's proceed. Question number 19, 30, question number 17. A gas is compressed isothermally to half its volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Then compressing the gas will require the same amount of work. Very simple. No yengo. Question number 17 ji yengo do hairo no hairo. It's so simple. Sidi ain doctors yagadra and the khali but no ye answer tagi ke hairo. Adiabatic process ka isothermal process ka curve sika mane heli compression da. Adum compression oigira moigira always adiabatic ne slope hele ko. Aduna kedoba again same initial volume and final volume chamane half of its volume the compressed or kadine ba. Aduna adu ibetar gadi work done zikaram mane heni. Chile. Very good. Adiabatic ne hele work done se ko. Kay no the work done as always the area under the PB curve neba on adiabatic ki makha da leba area duga isothermal makha leba area du adiabatic ki makha leba ne hele ko. Aduna compressing the gas isothermally or adiabatically will require the same amount of work. No lale. Which of the case, whether compression through isothermal or through adiabatic, requires more work will depend upon the no lale. Compressing the gas isothermally will require more work to be done lale adiabatic. Oh, the option number kay tare D tare ko. Yarba ma'am.
Yes,
Yes,
sir.
sir.
Kay yung expansion or magdi kayo niya.
Expansion oramadi isothermal na yaman.
Very good. Expansion or magdi isothermal na matakta laitra areas isothermal na yamdiba. Compression na adiabatic na yamdiba ko. So dugi clarity do laigadam ni ko. Now let's move on to the next question. Question number 18, an ideal gas is compressed to half its initial volume by means of several processes. Which of the process results in maximum work done on the gas? Hairo to this idea. Hey, Ernie, adiabatic Ernie.
Diabetic oil.
Yareko, azikta to give the guy to quick grab to catch a crack. She's adiabatic makada. Sir, Isochoric ni hello. Isochoric always work done zero ni ko mahidi kamnet. Yareko. Matang the question number 19 figure below shows two parts that may be taken blah blah blah. The heat absorbed by the system in the process AC will be okay. Okay, fine. Kay no ay handak marak siyam tunus na body ji tired oy gali ji kay question me am jay ni solve as taw daning manin taw is theory di takulo e kono ita taninga yaw de theory di loin solve taw ya do matam je to kona da ba ko 927 ay am solve taw ni okay yang ji angam ba kay dam dilo sila ba taw is dam loi habya pote da dam loi dre tos. Okay, fine. Question number 19. Figure below shows two paths that may be taken by a gas to go from state A to state C. In process AB, 400 joules over the system. Okay, in process BC, blah, blah, blah. The heat absorbed by the system in the process AC will be. So simple. Very simple. Hiro. Ngamudra. Kaya dito ni. Question mo na paro. Ngamni search into ngamni na hayo ko. Sir na hol is yung search holak ke. AC the heat cameras of the now. Chika cre. Delta QAB. So what is delta QAB? 400. What is delta Q BC? 100. Minus what is delta W BC? BC gidi work done C 6 lerni. Aduga 4 minus 2d 2. So 6 into 2d 12. 120. Delta Q AC name putokadesi. AC gidi kena. Trapezium, area of trapezium the half. Sum of parallel sides is 2 plus 68. Distance between parallel sides is 2. Is 10. So 2 go cray. 500 tagi keno torgati 500 minus 120 the miro ka. C minus is from secret plus lane kay lane of the 80 lane 80. So the 580 minus 120 the kay lane. 8 minus 2 the 6 la 460. 460 joules tabrang ma'am. Option number 8 tabrang.
Tay.
Tay. Sir na solve to is gyan tao to mi aura gyan ta drag sir adu step to gyan ta de na hero. Gyan tao to mi gyan ka tao to step ko aura. To zainer target di sir loin tare hero. Chetor ju kumo. Sazat. We don't have all day.
Tay, sir.
Tay, sir.
Saitobos, Tarbo, Rosban, Tarbo, Rosibina,
Tay,
Tarbo.
sir.
Tare ko, loin tanare ko. So okay, fine. Now let's move on to the next question. Question number 19 na. Question number 20. A monoatomic gas is concentrated having a volume. Very simple question. Question number 20. Question number 21 is puzzle. Question number 20 to 21 I don't know. Shaz is correct tired or anyway. 20. 20 dengan mudah. Question number 20 is a monoatomic gas at a constant pressure P having a volume V expands isothermally to this and adiabatically to this. The final pressure of the gas is like is this mali. Tausira taurosira sazaro yadra yam live question ne. But I need am lie high and we cannot we want to take on. Tausira taurosira sazaro.
Tausi, sir.
Okay, yeah, toss. So pressure, initial pressure P1 is P, volume B1 so V, V2 not 2 times of V, adiabatically to expands having a volume B expands this and adiabatically to a 16. Okay, fine. All right. So the final pressure of the gases have a P2 put away. Not P2 not take off. Okay, head PF hydro. P3 hydro. Final pressure put away. Okay, fine, yes. Grab a bit masami to pressure P expands a volume 2V. So okay, expand to work. So expand to agadi ki volume je darakani. Acha. Sorry, volume hingalaga pressure darakani. So sumain la ani. And kedarakani and then adiabatically to a volume 16B. Adiabatic tigina wang lo hidarani. Ina isothermal level. Adiabatic na kay sharp oy dine pa. Adu ibitaragadi ay soy sharp oy rectrade na soy loctose. The magic can be my graph second and can dito holorege. Comment daw sige. graph yektrasi yaida yabudi ko. But anyway, let's say my volume is V or money is not 2V or ko. Then see kitang sundan ge. Id V ga 2V ga sana na baitare ko. Aduga kaidoni hai matam si straight line nate ko si khara di slope lai ni ko the slope to yam lai te we wani slope lai tabdi nate lai di lai ko. Anyway, fine. Now the final pressure do kai yudina si final pressure P do adu kai yudina again as a graph yam du yam sum noi de he na khanganing be sum graph yek pe wani ko. Adu gadi final pressure putho u haibane ko adu di kai do bai yai having a volume V expands isothermally to a volume 2V, and then this got delta fin dp putho haibane ko adu now final pressure C final da lai si kai no adiabatic process oi ko final da aduna akoina kai khangi the P1 V1 is equal P1 V1 to the power gamma is equal to V2 V2 to the power gamma. So P2 is equal to V2 to the power gamma by P1 V1 to the power gamma. Natra? Okay, fine. Now, volume di kayo, mo has the pyramid di 16 times of V. So 16 means zero. Okay. 16 times of V to the power gamma. And P1 din kayo with the adiabatic ki pressure da. Pressure volume V expands isothermally to a volume 2V haven't gone now. Isothermally at constant temperature. So process 1 at constant by the process 1 I see konto see asing move the any palm photo han thumb one but asing with the iso the can never go P PV P1 okay the isothermally P1 V1 is equal to P2 V2 never isothermally. Aduna kaidoni hai matamda ai hajik P aina hajik kai pami habida magi P2 je pame ko nei si ngaudana ko kamain tawni si se noi ngaudana ba kamain tawzige habida ai si 2 ga 3 ga sizinarga natargadi nei ngarni soidamki aduna pekhadabudi dum ga isa gyan tar lore ko si P2 V2 P3 V3 and P3 pame so V3 lerni and P2 and V2 lerni habidi kaino the process habidi kaino the sine state 1 and color sine state 2 and color sine state 3 and color so this is isothermal ko ana noi dugi zo mo hypet kaino ma tharamgi natragadi noi ngar choice isothermal the ne in ne kainin lowi kangra 1 then 2 bu chatlen lowe state 1 dagina state 2 da chatlen isothermal da adiabatic tana 2 dagina 3 da kai noi koli dana adiabatic na ko adiabatic na state 2 daina state 3 da chatlen logadoine yare ko so adu lere adu itaragadi hazik akoina kaidoni ha matamda aina zik P2 ga V2 ga pame ba ko ana V2 di mo pyramid 2V na ode P2 pama ga di kaidoni ha matamda P1 di P V1 di V and V2 di kaino 2V the V2 di 2V na tra yes so P by 2 ta tra and si say aina zik P by 2 here ne ba ko aduga V2 sina kaino V2 sina 2V ne ba ko sumai le ni adu di it's so simple kai tare explain to when sang is so which is equal to kind of the again let it be 16 V to the power gamma and here 2 ka creduna PV dum tare ka now gamma di kind of 5 by 3 so 16 aega V to the power 5 by 3 ka kai no ma soy bra to isa soy deda 2V to the power gamma hai dam ni si Yareko. Aduna 2v to the power gamma. So, okay, fine, no worries. Already kay tarani. Have the I see 16 to the power gamma is wala mabaka. Aduga sige PV zim soire. So I know is B to the power gamma is crane low isana ko. Adu di kay tarani kambra. Adu regadi CC so my 16 to the power of 5 by 3 am le ko. And P le ko. Aduga 2 to the power 5 by 3 minus 1. Kaya divided by 2 am le ko. So which is equal to Aga P makala ko moy gida na P matatuloy na ay kainom this for
Sargi B3 제 makada laktoyne.
V
Aduga
program
B2
makala kita chume si na matatuloy gida ba chumi ko yar ba
Oh, sorry.
okay fine yare adu gadi kay do re matamda okay fine ko so main torsi no ngawre ngo si 2 to the power 5 by 3 minus 1 hai ko. So 16 to the power 5 by 3 is 16 to the power 5 by 3 is 2 to the power k now have the 4 never go and 4 into 5 by 3 in line. So 5 for 20. So minus 20 by 3 line ko. Aduga times p line. So duragadi CD kar nungai trabana. 2 to the power k have 3 layer ko 5 layer ni minus 3 layer ni minus 20 layer ni ko times p. Of the p yani so 20 ga kaido ba 23 dagi 5 kaido pa where to read 23 dagi 5 kaido ga di 18 tare ko 18 by 3 di 6 of the p to the power minus 6 layer sorry 2 to the power minus 6 layer ko na 2 to the power minus 6 times of p adu di kay tani have the p by 64 p by 64 tabre option number C tabre mo kanam kumar writers tabro
Taye.
taiko so sir na kino to easy sir na sol to easy gyan tao bro taiko okay yani buka okay fine so taiko rosivina tare sinthoi tare lakshmi tare so next question C question yam phaza given hai tare ka tausi things so phali phaza sim to lo sho sing si I'm also tired. I am tired. So, a thermodynamic system undergoes cyclic process A, B, C, D, A to B, B to C, C to D, D to A, as shown in the figure. The work done by the system in this cycle is an Isobaric. So, very simple. But again, this is no confusing. This is solve to me or ba kang ba mi or kang the mi or hello kang the sir I
Khangde.
Kang de Anjali Kang de. Say the boss.
Kang
Kayla Kang de. Say the boss Kang bra.
Kang de sa.
Kang de. Atay budi cheta kumani ka. Kang ba yaw bra. Kang de Lakshmi Kang de. Sintoy Rosivina Rosban kumo. Anyway, ka start talking. Work done. Work done in the process A B C D A is equal to work done. A then B bawda hana putwa plus B then C bawda minus. Okay, and plus E work done from B to C plus work done from C to D plus work done from D to A natural ask is money. AB, BC, CD, DA. Yes, fine. So work done from A to B. A to B ki work done se kena half into sum of the parallel sides se P naught plus 3P naught. Okay, now 4P naught. Distance between the parallel sides se kena V naught. Into them into V naught. Minus kay B to C D negative ne buka aduna 3 into 3P naught into V naught. C to D di amuk plus ne buka expansion tawbanina aduna kayna half into sum of parallel sides se kayna 3P naught plus isi dum direct irage pa 3P naught plus P naught 4P naught aduga C distance se kayna V naught aduga plus DA di minus ne sorry kayna si na P naught ka V naught ka adudi kay tarne have the C kayna 4 by 2 ka 2 there 1 yeah so 4 half plus half T1 tare dana ka so 4 P naught V naught minus 4 P naught V naught audi kai tare 0 tabra si kise 0 taita de amti yung tabra yung option number D tabra ma'am
tay
like sida no in section ga dawa master kinam hai ge ko keno to bi yaw bane ba yamna misunderstanding laina ba khara azum ain sum hana si question ji thengna ge ta ogdan in a cyclic process is 0 ni kind of haizal ko there is no such thing cyclic process to work done 0 ide internal energy 0 oi work done 0 ide work done kam kan 0 oi same path hala ga 0 oi but cycle again aduga ke do same path na 0 ide ko aduna adu haizal lage ta a dai hauraga a da dum hale na work done 0 oi ni have laite ko internal energy 0 oi ni work done 0 oi roi heat 0 oi roi yare ko id work done 0 with device hit to 0 or hit to no positive or work done to negative or money do hit the negative or work done positive or money whatever but see the work done see this is a cyclic process see the 0 oidina see is oidrasu yaeva see adum oini have late gyan tai ko ja auna sigi kaidoba sigi matang 0 oijabe wani atopa matang for example let's say aina sigi the kitang shape si kitang twist or matam the cyclic oijara so have the initial point the hanjara agasu 0 oini have late ba gyan tai ko ja tai ta de sigi confusion ina bane ba cyclic or ga di 0 oini na cyclic the work done 0 oide ba no khanga da ba kari di 0 oi internal energy 0 oi ba have the initial point and final point to chamana maina there is no change in internal energy because you know the internal energy is state function never same state halaga di kamai to na difference like internal energy same state we get everything same we get internal energy we get pressure we get temperature we get volume we get everything but work done is the state function natte madi path function ni aduna madi 0 we ni have like but internal energy gumba di same state halaga di 0 we ni buka so sir na hai si gyan ta ubra me amaji kita
sir.
Okay, fine. So ngasi this is the local I'm really tired. So see you tomorrow. Thank you for the class. Thank you everyone. Good night everyone.
Sir.
Okay. Thank you and good night.